right, guys, I'm going to go over day 10 in the packet. It says state if there appears to be positive, negative, or no correlation. Just as a reminder, the correlation is the slope. So if I were to draw a line through the middle of my points, that definitely has a positive slope. And because it has a positive slope, it has a positive correlation. So number 1 would be B. Same thing for 2. If you draw a line through the middle, oh wow, my lines are pretty. But if you draw a line through the middle, it doesn't matter how bad it looks, they're still all going to have negative slopes, so it will be a negative correlation. So that's how you do 1 and 2, and there are a few other questions like that. 3 gives you a table, and I let X be my miles and then Y be the cost, and that's actually what they have graphed. They even figured out the equation for you, which is where they plug these in L1 and L2, and they got their graph. And then this is the equation of the line of best fit that goes straight through the middle of your data. Positive correlation, positive slope. I would say a pretty strong bond between the points and the line. And then it just asks a couple open-ended questions. It says, what does the slope of the line represent? Well, change in Y over change in X. So that's just going to be your cost per mile. And that's what I put in words. And then B says, what does the y-intercept of the function represent? Well, the y-intercept's a little bit below the 50 mark, but that's just the cost without any mileage, according to the flight, and you're looking at the distance traveled. So that's just the cost without any mileage. And then C says, using the model, what would the cost of a flight be if you traveled 1,450 miles? Well, since miles is my X, all it wanted you to do was plug that value in the equation as X. So that's exactly what I did. It asked me to round to the nearest dollar amount. I didn't. So this will be about $153. So again, when they give you the mileage and you have the equation, miles was your X. I just literally in parentheses plugged it in. And you would do, please excuse my dear Aunt Sally. So you would multiply these guys first and then add back the 35.4. Same thing for D. It asks you for the cost when X was 4,475. So you will plug that in as your X value. And then it asks to the nearest dollar. So in dollars, that would be 397 if you rounded to nearest whole dollar. But that I was just trying to make it money. And then the last question's a little bit different. You're solving for X because it gives you the actual cost. So it's saying like, what is the mileage if the cost was $140? So in this one, you're not plugging in the miles, you're actually plugging in the cost. So Y is 140. But you still solve it like an equation where you would subtract 35.4 and then divide it by your slope. And it said answer to the nearest mile, so I did 1,293. And you have a few of those. Question 4 is asking you to compare, tables and the graph as well with the equation. Very, very similar question. Make sure you know whether or not you're entering in the values as X or Y. 5 is just like number 3 as well. And 6. These are very important questions because understanding slope and y-intercept is a huge part of 8th grade and a huge part of Math 1. So now we're going on to day 10 application problems. I'm going to go over question number 2 where it says ticket prices to Funland. So if I drew a line through the middle of my data, it has a negative slope. And what we never really got to talk about is if it's a negative slope, your X and Y values don't agree. Meaning like it's a negative thing because they're going in opposite directions. One has to increase and the other value has to decrease. So like if your X value is increasing, in order for it to be a negative slope, your Y values would have to do the opposite thing. So if X increases, Y decreases. If Y increases, then X would have to decrease. So they don't agree, and that's a negative thing. So C was the one that actually made sense because Since looking at my actual scatter plot, it was a negative slope. C would be the answer because the cost per ticket decreases as the number of tickets purchased increased. They are different. They're opposites of each other, so that's why it would have to be C. When you look at A, they're both increasing. B says it's unchanged. Obviously, it's being changed. And then D, no relationship. No relationship is like when you have points that are literally scattered all over your graph, and there's no relationship between X and Y. All right. Number 3, you've got a scatter plot, and it's showing the time that cheese has been aging and the amount of lactic acid present in the cheese. And then so X, we've got the age of the cheese in days, and then on the y-axis, you've got lactic acid parts per thousand. So again, I drew a line through the middle, and notice this is a very positive, strong relationship. Positive correlations, they have to agree. So it's positive when you agree, right? So either your X and Y have to both be increasing, or your X and Y have to both be decreasing. So when I actually read my answer choices, and it says most strongly, but they have to agree. So the longer cheese ages, the more lactic acid is present. So I've got more and more. So that is an agreement. So that would be a positive correlation. B says the longer cheese ages, the less lactic acid that's present. That would have to be a negative correlation because you've got more and then less. So they're not agreeing with each other. C says the amount of lactic acid present remains constant. Again, not a constant thing. And then no relation, again, is where you have your scatter plot with the points everywhere. And this obviously has a relationship, a pretty strong correlation between the cheese age and the lactic acid that is present. All right. 5 and 6, I think you are good to go. They're pretty easy questions. I did want to go over 8. I think that one was the last one that I wanted to go over. So it says you've got a scatter plot, and it's showing the absences in a week of classes, and the classes obviously have different sizes. And then Trevor's making conclusions. The thing to make note of is the word best is used here. So when you want to like talk about a scatter plot, and he is saying that there is a positive correlation. So I kind of drew a positive correlation, which some of the data is positive, but you would have like 4 really, really strong points that would kind of, actually 3 really strong points that would make it not a positive correlation. And since there's not that many points anyways, that is definitely not a true statement. So A said the largest class size did not have the most absences, and that's true. But again, that doesn't best describe why his conclusion was incorrect. B says the smallest class size does not have the least amount of absences, and that's true because, you know, the class size of 30 is the one with the least number of absences. So again, that's true, but that's not the best statement. The best statement is C. The data shows no relationship, and this is an example of no correlation because even though some of them are kind of going in the same direction, overall you've got points scattered everywhere. And when you look at all of the data points, this one best describes the whole picture. D says the data shows a negative relationship, and again, that's not true. That would mean they all have to go this way. So C would be the best answer. And then day 10 goes to number 10, so don't forget those as well. And when you're done, you are done with the second packet. Whoop.